Now let us look at this ordinary differential equations, wherein we'll try to look out on the initial and boundary value problem. Okay, now let me take up one example of that. Considering the differential equation as x dash is equal to 2t and multiplied into 1 plus x square. Okay, now this is our first order differential equation. So let us find the solution for this. Okay, this is dx by dt, okay, which is equal to 2t or 1 plus x square. Now if I put all t terms on the left hand side and or the x terms on the left hand side, so we get dx by 1 plus square. So putting all variables on one side, 2t dt. Now on integrating this, we get this as tan inverse x is equal to, this is t square plus c. Now x of t would be tan of t square plus c. Now where c is an arbitrary constant, where c is an arbitrary constant, is a solution of the given equation. For each value of c, we get distinct solutions. In physical, or we can say that we get a one parameter family consisting of an infinite number of solutions. In physical applications, quite often we need to accommodate extra constraints, which may many times determines a particular solution from the one parameter family of solution. For example, if I we may obtain a solution which satisfies the requirement, like, okay, so if I consider x0 of 0, okay, which means that to determine a solution which passes through the point that is 0 comma 0, okay, so x of 0 is equal to tan of 0 plus c. So you get x of 0, which is tan c, which is equal to 0. Hence c is equal to 0. Okay, the desired solution is then given by, so x of t is equal to tan t square. Okay, and we can say that t lies between 0 and square root of pi by 2. Now it is easy to see that, okay, by verification of that. Now let us consider the equation of order 2. Okay, now for example, if I take x double dash plus 7x dash plus 12x is equal to 0. Okay. Now the auxiliary equation corresponding to this would be m squared plus 7m plus 12 is equal to 0. So you get the roots are as minus 3 comma minus 4. So we get x of t as, if I consider alpha, e to the power of minus 3t plus beta e to the power of minus 4t. Now, is a solution existing on minus infinity less than t and less than infinity. Here alpha and beta are the arbitrary constants. For each choices of alpha and beta, we get a distinct solution. Hence, we can write that as alpha e to the power of minus 3t plus beta e to the power of minus 4t. Okay. Now is a two-parameter family of solution. To determine a specific solution of this family, two conditions are necessary. For instance, the conditions are x of 0 is equal to 0 and x dash of 0 is equal to 1. Okay. It then follows that x of 0 is equal to alpha plus beta, which is equal to 0. Now x dash of 0 is minus 3 alpha minus 4 beta, which is equal to 1. Now these are simultaneous equations in alpha and beta. So we can verify that alpha is equal to 1 and beta is equal to minus 1. Now the specific solution is therefore given by x of t. By substituting the alpha and beta, we get x of t is e to the power of minus 3t minus e to the power of minus 4t. Okay, and minus infinity less than t less than infinity. Now to determine a particular solution of first order equation, we need one condition, while in the case of second order we need two conditions at the same value of t. Intuitively, we conclude that for the nth order we need n conditions. So so that can be written as x of a is equal to a naught x dash of a, which is a, you can consider this as alpha 1, okay, and x n minus 1 of a is alpha n minus 1 at t is equal to a. These conditions are called initial conditions. Now the differential equation together with required initial conditions are called initial value problem. Observe that an initial value problem is determined by the differential equation, and the initial conditions. A change in either of them would mean a different initial value problem. Now let's consider a second order differential equation. So that is x double dash plus x is equal to 0. Now indeed, a solution is, we can find that auxiliary equation is m square plus m is equal to 0. So okay, so you can write this m plus 1 is equal to 0, and then you get m as 0, and or okay, so you can get this here as x of t, which is c1 cos t. Now this is m square plus 1 is equal to 0. So m as plus or minus I. Okay, you get c1 cos t plus c2 sin t. Okay, now this is minus infinity, t less than infinity. Okay, now where c1 and c2 are the arbitrary constants. Now let us assume that one of the following conditions is to be satisfied by a solution. So let me consider x of 0 is equal to 0 and x of pi by 2, which is 0. Okay, and we'll consider another one, x of 0 is equal to 0. Now x of pi by 2 is equal to 1. Okay, and the other one is x of 0 is equal to 0, x dash of pi by 2, which is equal to 0. Okay, hopefully the two constants c1 and c2 are determined by one of the above conditions. So we note that the two conditions are given at two different points, namely t is equal to 0, t is equal to 0, and t is equal to pi by 2. It is easy to verify that the solution corresponding to the three sets of condition are given by, so this would be x of t is equal to 0 for the condition 1, 2, we get x of t is sin t, and you have x of t is c2 sin t. Now respectively, existing on minus infinity to infinity. Note that in the case of the solution 3 above, we do not get a particular solution but infinite number of solutions, since C2 is an arbitrary constant. Here the conditions given in 1, 2 and 3 are boundary conditions stated at 0 and pi by 2, and the given equation together with boundary conditions are called boundary value problem. Okay, so please subscribe on my channel for any other queries or problem related to mathematics. Thank you for watching. Please subscribe.